Hey guys, hello and welcome to yet another interactive session from Oda Classes, my dear kids, which says for a better future, learn today, right? So if you need a better future, you need better teachers like us who are there at Oda Class. And you can see one thing, very interesting thing, the word today is not even complete without the word Oda, right? So better teacher, better future, right? So my dear kids, let's start the session with a very interesting question, okay, that is there on your screens. Very interesting questions, right? So the question says, which of the following is the best conductor of heat? So I want all of you to just pause the screen and think about the answer, correct answer. So now I think basically you have landed to the correct answer, which is correct according to you, right? So I think majority of the people will say that out of these substances, silver is the best conductor of heat, right? So because silver is a metal, so for sure silver is the best conductor of electricity. Oh, sorry, heat, right? So as it is a best conductor of electricity, but my dear kids, it's not the best conductor of heat. Yes, you heard me right. Silver is not the best conductor of heat. And my dear kids, the correct answer is diamond. Right. You are hearing me right. So diamond, being a non-metal, is the best conductor of heat. Now you will be like, so diamond does not have any free electron. So how it will conduct heat? Yeah, that's a very interesting question and you should ask this question. Be curious, right? So my dear kids, being a non-metal, how diamond conducts heat, right? So the reason behind this is it has a very regular arrangement. It has a very regular arrangement of the carbon atoms. It is made up of carbon atoms, right? So it has a very regular arrangement of carbon atoms. And my dear kids, these carbon atoms are very strongly bonded to each other. So first of all, a very regular arrangement of atoms. At the same time, they are strongly bonded to each other. Now what happens? How the heat conduction takes place? So as soon as the heat is transferred to the, let's suppose this is diamond, right? So what happened? The atoms, they start to vibrate, okay? They start to vibrate at their particular positions and the heat is transferred in the form of waves. Yeah, you are hearing me right. It transfers in the form of waves that are known as phonons. There is a technical name for this that is known as phonons. I'm not discussing this part into very deep because this is something related to quantum mechanics. Let's understand this fun fact as well. So I hope you know diamond is the hardest naturally occurring substance. All of you know, right? But out of all diamonds, the black diamond, okay? Black diamond, kala diamond, the black diamond is the hardest of all diamonds, okay? And this black diamond is also known as carbonado, okay? This is also known as carbonado. You can also ask this question, ki sir, why it is black in color? So when it is formed, right, under the earth's crust, when it is formed, so it also contains graphite, and because of this is black in color, right? And one more interesting fact, because you are here on Oda Class, so you should know about this. Lonsdaleite, the name is Lonsdaleite. So Lonsdaleite is even harder than diamond now, okay? Is even harder than diamond. This is like some people also call this as hexagonal diamond, okay? How it is formed? I will just give you a very brief introduction about this. So Lonsdaleite are, you can say, are formed when the meteorites, okay? Meteorites, the meteors which enters the earth's surface that are known as meteorites. So the meteorites contain some graphite and when they fall, because of high temperature and pressure, the graphite is converted to the hexagonal diamond that is known as Lonsdaleite. So remember, Lonsdaleite is a material which is even harder than diamond, right? Pretty much clear, right? Very good. Okay. Now, a very interesting question is there on your screens. Please see the question. You have observed this thing, but you don't know the correct answer. You don't know the reason behind this. Okay. So first, I want all of you to have this curiosity about things, right? Go and observe. Always have the curiosity about things. Insatiable curiosity that we can say, right? So the question is, why copper wires are used for electricity transmission in houses? In your house, you have seen copper wires, right? While you can see aluminum wires are used for the overhead power lines. Why we are using two different metals for different purposes? What's the reason why we cannot use aluminum at our home and copper wires in overhead power cables? Okay, so let's dive deep into this concept. So first of all, why we are using aluminum in overhead power cables? Let me tell you about this part. So basically, if I'll talk about the cost, okay, so cost of aluminum is greater than, it is, my mistake, my bad. Okay, my dear kids. So cost of aluminum is less than cost of copper. Okay. The first reason is this. Second reason, my dear kids, the weight of aluminum, okay, weight of aluminum is also less than copper. Now, what's the advantage of weight here? What's the advantage of weight? So overhead power lines where they are used, let's suppose if the power or let's suppose if the electricity generation takes place in a particular city. Let me take an example, Kota. From Kota, this power, right, is being transmitted, or this electricity is being transmitted to the districts, different districts. Okay, so how they are transmitting this? They have towers for this, right? They have towers for this. So this is where the power is generated, power station, and this is your city. Let's suppose your city, right? So if I use copper, I have to use more number of poles. But if I use aluminum, I have to use less number of poles. Why? Because the weight of copper is more, right? So this will raise my cost. The cost will be raised. Okay. And one more advantage is that aluminum forms a protective layer over itself. Copper also forms it, but it takes more time. Aluminum forms a protective layer, right, which protects the inner layer of aluminum metal from the atmospheric conditions. Okay. So the very first concept is clear, why aluminum is used in the overhead power lines. Now, why we cannot use aluminum for electricity transmission in our houses? Now, what's the reason behind this? So the reason behind this is the conductivity. Okay, the electrical conductivity, my dear kids, the conductivity of copper, okay, is greater than aluminum, right? So let's suppose if I have to use this cross section of the copper wire, for same conductivity, the cross section of aluminum wire will be like this. For same conductivity, you have to use a thicker wire that is made up of aluminum. Now, this is very, very bulky, right? That's why we are not using the aluminum wires at home and we are using the copper wires, right? Pretty much clear, right? That was a very interesting question that we have observed, but we don't know the answer, right? So, my dear kids, if you have learned something different, you are here on ODA class, and for such interesting facts, for such different and weird facts, kindly please like our channel, share this video with your friends so that even they can learn something new, and don't forget to download the ODA class app.